Hi, this is Regina. In this video series, I want to discuss rates. Let's get some ground rules sorted out first. So what is rate? A rate is a change of an event per unit of another event. For example, for speed, a rate is miles, change in miles per 1 unit of another parameter. Harold can type 600 words in 5 minutes. So it's change of 600 words per 5 minutes. Miles per gallon. That's a rate. Pages per minute is a rate if you're looking at typing speed. So we need to understand that a rate is one ratio of numbers. For example, here you have 75 miles per 1 hour. And by comparing two different ratios, you can actually calculate the missing parameter. In this case, the missing parameter is hours. How long does it take? Again, the 28 miles per gallon, because the denominator is 1, that's essentially the rate, 28 miles per 1 gallon. If you look at the question, you notice that 4.5 gallons of fuel is given. And 4.5 will have to go in the denominator position to make the rates and ratios equal. And then this is what we can look for here. If a landscaper cuts 1.6 acres of grass per 1 hour, then our rate is actually 1.6 acres per 1 hour. That is our rate. If we change the bottom number to anything other than 1 hour, it becomes a ratio. So at the same ratio, 8 acres will take how many hours? And then we can use our standard algebra technique to solve for this. A train leaves New York at 1 p.m. going at 50 miles per hour. Again, we know the rates, 50 miles per 1 hour. And at the same rate, if the train needs to travel 90 miles, then we can figure out how many hours it takes. It turns out that the train would need to take 1 hour and 48 minutes. So once we know how long the train takes to travel, we can say that it'll arrive at 2:48 p.m. Okay, that was my introduction to rates. The take-home message here is that the rates is basically a ratio with the denominator unit being 1. We need to be careful of how we set up the units, and when we set it equal to another ratio, the units have to be lined up. Another type of rates problem is that you can have two people paint a room. Here, Ann takes 2 hours to paint a room, and Barbara can paint the room in 3 hours. When they work together, their work rate is the sum of the rates working separately. How long will it take for them to paint the room if they work together? So let's figure out the combined rate first. And once we know the combined rate, we can, by ratios and proportions, answer the question. So now if Ann is taking 2 hours to paint a room, then she basically is doing half a room per hour. So notice that I'm trying to keep my denominator at 1. And Barbara is painting the room. She's basically doing 1/3 of the room per 1 hour. If you need to know how I got the fraction, it was one room per 2 hours. So to make the bottom a 1, I was forced to divide this by 2, so I have to divide the top by 2 as well. Similarly with Barbara's, she did one room in 3 hours. So if I wanted to make the denominator 1, I was forced to divide both top and bottom by 3 to get 1/3. So the combined rate is essentially 5/6 room per 1 hour. Okay, now that we know the rate, which is 5/6 of a room per hour, we can set this equal to whatever they want us to solve. And in our problem, they want to figure out how long will it take for them to clean the room if they work together. So we are looking for the time. And we know how many rooms. It's only one room that they need to paint. And using traditional algebra, we know that it'll take them 6/5 hours, which is 1 hour and 12 minutes if they work together.